In this lesson, we are going to learn how to use materials. We've been using one material until now, which is the mesh basic material, but there is a lot more to do with materials. So, materials are used to put a color on each visible pixel of the geometry. So you have your geometry, which is supposed to be somewhere in front of the camera, and the materials will put a color on each visible pixel of that geometry. If the geometry is invisible, like it's behind the camera or outside of the field of view, well, obviously nothing will be shown, so no pixels to put a color on it. The algorithms are written in programs called shaders. So the programs that are supposed to decide of the color of each materials are called shaders, and the good thing is that we don't need to know how to create our own shaders, at least for now. We will learn shaders together, but for now we can just use built-in 3GS materials and we will get a result that will be shown on the render. Yeah, about the setup, well actually the setup, if you run it, you get a dark render because there is almost nothing in it. No red cube, no textured cube. We have our orbit control, but we cannot even see the result because we have nothing in the scene. This is the perfect opportunity so we can start from scratch and rediscover what we already did, which is creating meshes, creating materials, creating geometries from the start. So yeah, let's first prepare our scene. We are going to create three meshes. We are going to create a sphere, a plane, and a torus. Why doing so? Well, it's because we want to be able to enjoy the materials. And some materials will act differently depending on if it's a plane, if it's a curve, if it's a sphere, and stuff like that. So yeah, let's start by creating those. And the interesting thing is that we are going to create only one mesh basic material for all three meshes. So let's go. I'm going to create an object part inside of my code. And I'm going to create only one material. So it's going to be material equal new 3 mesh basic material like this. And I'm going to use it in multiple meshes. So then I can create the meshes I just said, which are a sphere, a plane, and a torus. So let's go. We create the sphere. I'm going to name it not mesh because now we have multiple meshes. So let's find better names. So it's going to be sphere, and it's going to be 3 mesh. The first parameter will be a geometry, and it's going to be sphere. Buffer, don't forget to use buffer geometries instead of just geometries. So there is a sphere geometry, but we are going to use a sphere buffer geometry and use those parameters. It's just about subdivision and the size. You can tweak them if you want, but the result should be fine. And in the second parameter, if you remember well, the mesh needs the material, and we already created one material here. All right, that's cool. Then we can, you know what, let's just test that sphere. So don't forget to add it to the scene, and I'm going to do scene add sphere. I just want to make sure that it's working. As you can see, I have my sphere right here. So we can create the other one. I'm going to create the plane in the center. It's going to be plane equal new 3 mesh again. The first parameter is the buffer geometry, so it's going to be new 3 plane buffer geometry. If you need, just open the documentation and try to guess all of this. Maybe you should pause the video and try this on your own in order to practice. So pause the video and get back. Maybe you will have trouble, maybe you won't be able to do it. It's perfectly normal. This is all new. You need to practice and you will get there, don't worry. So the parameters of my plane are going to be just 1, 1. And again, I'm going to use the material. And then I can add this one to the scene. And one cool thing I can do, instead of using the scene add twice, what I can do is add multiple objects at once with the add. it's the same. It's the same result. It's just shorter to write. So we get this. It's working fine, but the problem is that both meshes are at the same place. So we are going to move the sphere on the left. And to do that, try to do it on your own. Again, I'm going to do sphere, and it's going to be position. Try to guess the axis, and it's going to be X. And I'm going to use something like minus 1.5. Yeah, that's it. All right, I have my sphere, I have my plane. I cannot see the back, which is normal. We are going to talk about this. I can add the last one, which is a torus. So I'm going to do torus equal new 3.mesh again. And you're going to put those parameters. Yeah, it's going to be new 3 torus buffer geometry. Always use the buffer version. It's going to be 0.5, 0.2, and the subdivision are going to be 16 and 32. And again, we are going to change the material. We are going to use, the material. I save it's not working because I forgot to add it to the scene, which is a classic mistake. I always do that. So I add my torus to the scene. It's here. So I cannot really enjoy it because it's in the middle of the plane. So I can move the torus position X equal 1.5. So it's positive 1.5. So it gets on my right. And here is my donut. Okay, cool. I did only one material, which is great for us because I can change all objects just by changing this material, and I can do something like this. And as you can see, all the objects became red because I have only one material for all these objects. Actually, having one material is better for performances. It's not a huge improvement, but if you have hundreds of objects in your scene and they all have the same material, it will be better, all right? So try to materialize those materials. And another thing I didn't talk about is that by default, if you don't put any color, you get a white color, which is fine. You can just instantiate it and see and get a result. All right, the next part is about animating those, because we are going to use materials that react to the environment. We'll see how and what exactly it's going to happen, but we want our shapes to move around so we can enjoy those effects. So let's go to the tick function, which is at the bottom, and we are going to update objects in here. And I'm going to rotate all the objects, which is the sphere, the plane, and the torus, on the Y and on the X axis at different speeds, so we can really see different position. So it's going to be sphere, rotation, not position, Y, in lowercase. And I'm going to use the elapsed time. Remember the elapsed time? I can show you in the logs. Look at this. I get something like that. It's just how much second has been spent since I refreshed. And I can use this value in here. So I did it on the sphere, which is not relevant because it's a sphere. You can rotate a sphere, you won't see much of a difference. Maybe we can see like on the side, but it's not really useful. So I'm going to do the same on the plane and on the torus, like this. And as you can see, it's rotating slowly, not too fast. You don't need to move too fast. Then I can do the same on the X axis. So I can just change all of those. And I'm going to change also the speed for a little faster, like this. All right, so it rotates in all directions. You don't need to rotate in the Z axis because rotating two axes can give you all the direction. All right, we can move forward. We are going to need textures. Why? But because simply some materials will enable features that need textures. So we are going to use the normal map, the ambient occlusion, and stuff like that. So we need textures. Let's load all the textures. Yet again, what you can do is pause the video. Don't watch the code on the top left part of this video and try to do it on your own. You have multiple textures you can load here. In the textures folder, you have the door textures. Load all of them. We have the environment map. We are going to talk about this later. Do not load the environment maps. We have a gradient. Load the first one, which is 3.jpg, and load one of these matcaps. So in the matcaps folder, load only one of these images. Okay, let's go. We are going to do it together. You can do this at the start. I like to load things at the start of the code. So I'm going to write textures. And if you remember from the previous lesson, we are going to use a texture loader. So let's go. Const texture loader equal new 3.texture loader like this. No error, cool. So I can go forward. I'm going to load the door first. So it's going to be the exact same code. I think it's the exact same code as before. So door color texture equal texture loader load, and the path starts from the inside of the static folder. So we don't write static. All right, you have to write from the inside of the static folder, and don't forget the first slash. It's not mandatory, but you might have troubles in very specific situations, which we won't cover. Textures door color .jpg, and I think that every images are JPEG. Yeah. So what you can do now, I can test it if I want, like this. No error, which is good sign. And I'm going to do for the color, I'm going to do for the alpha. So the alpha, the ambient occlusion, the 8, normal, metalness, roughness, and that's all for the door, which is already a lot. So it's going to be alpha. Ambient occlusion, we've talked about those, but we are going to use them. So if it's not clear, it's going to be clear at the end of this lesson, I hope. And anyway, we are still going to use those kind of things in the future. Metalness, I think, maybe I got something wrong, we will see quite shortly. And roughness, and here I'm going to change those to alpha. Ambient occlusion, be careful with lowercase, uppercase, it's really easy to do a mistake. I could have prepared all of this, but I want you to practice loading things. I have the 8, the normal, and we do a lot of mistakes doing those, so it's good to do those mistakes right now together, and we can resolve those mistakes. Maybe I will do some. Metalness and roughness. Like that. All right, I think I got everything right. Let's just save. If there is no error, like if you load a bad texture like this, you get an error. So the browser couldn't load this texture. So if you have an error, pause the video, fix the path, and get back to it. Get back to the video. Then I told you we are going to load other textures. We are going to load a matcap now. So I'm going to load the first one, and you will understand what are those, all right? We just need to load them for now. So I'm going to do matcap texture, singular. As you can see, I use very long variables, names, but I like this. It's like telling a story. I like long variables, and you know everything about it just by reading the name. I know it's a matcap texture. I could use MTCP or something like that. That doesn't mean a lot. If I get back to a null code, I will be completely lost if I use those kind of things. So I'm going to use matcap texture, and as always, texture loader, load, so it's exactly the same, and the path is /textures matcaps, like with an S, and it's a PNG. Be careful, I use PNG for those. And the last one will be a gradient. Not much of a gradient because it's very, very small, and we're going to use that. So it's going to be gradient, and here it's going to be gradients 3.jpg. All right, I save, no error, great, let's continue. So I have all my texture ready, and until now we use the mesh basic material, which applies a uniform color or, as we saw in the previous lesson, a texture on the geometry. So if you search for material inside the documentation, you get everything about materials. And we are going to test many of those. Not all of those, actually. I should not have written all, but many of those. The most important ones, at least. First, we are going to start with the mesh basic material. We already know a lot about this one, but we need to learn a few more things. So I get back to the WebGL experiment. So yeah, mesh basic material, it's the most basic material, obviously, because it's in the name, but we didn't cover all its properties. So let's get back to where we instantiate the material. It's over there, right here. And first, yeah, there is one important thing to understand about materials. So we are going to test this on mesh basic material, but it will work with most of material we are going to see after. If we want to provide an option to this material, let's say an option we already know, like map, we can do door, color, texture, all right? And this works just fine, like we did before. So it's exactly what we did in the previous lesson. If you want to apply a texture to a mesh basic material, you use map. But there is another way of doing it. It's by removing this part and doing it after. So if you remember, the property was map, and I'm going to do it after. So I'm going to do material, map, equal, and I will use the same thing, which is door, color, texture, like this. And I get the same result, all right? So there are two ways of doing this. Most properties support this, but there are going to be exceptions, and we are going to see those together. And this will work not just with mesh basic material, but also with other materials. All right, so this is the other way of doing it. Let's talk about the color. So if I remove this, I get this result back. I can change the color, which is a good example, because as you saw earlier, we can do color red, and this will work. But if I do material, so I will let the map just comment it, so comment the map. If I do material color equal red, and I remove it from here, we see that we are going to have a problem. The problem is that maybe we can provide something like this when instantiating, but once the material is instantiated, if you log material color, so I'm going to comment this part, you will see that it's not just red, it's something like this. And we saw that. It's the color class. If you write color in the documentation, it's that class. All right, so maybe when instantiating, we can put a color directly in the value, but once it's done, you can change the value of the class, or you can reinstantiate a new one. So we are going to do both. So if I want to change it, we can do color and use the set method. So color is the color class, and I can call set, which is over there. And I can't put anything I want here. So I can put, I don't know, yellow or something like that. I can remove it from here so you can really enjoy it. And as you can see, it's working. So we got a pink purple thing. Or we can do equal, but we have to provide an instance of color, and we can do that with new 3 color. And here we can put a value like yellow or pink. Let's put pink. And we get a pink, all right? It's not the same pink. If you want the same one, it's going to be something like this. I think I used that. Yeah. You can put many values here, as we already saw. You can put a short version, which is like this. We get the same result. You can put the name, like pink or anything, or purple, or whatever you want. We can see much of the purple. You can also put RGB, which is interesting. Why not? And we get something red. Yeah, and we can also use the JavaScript version, which is 0xFF0FF, FF00FF. And we get something like that. Alright, so this is the color. We won't spend too much time on it because we already saw it. One interesting thing is that you can combine the map and the color and look at the result. We get the map, so we can see the door texture, but we also have the color that merge with it. If I try another one, I don't know, let's use a green one. It's going to look like this, and I get a green door. All right, we can add like a tint. I don't know exactly how you say that. All right, we can comment this. We also have access to wireframe. We already saw this one, equal true. And we can see the triangles. So not much triangles here, but a lot in the torus and in the sphere. We can play with the opacity. I always comment to not merge everything, but you can try them together. So if I merge all of these, you can see that I get a green texture with also the wireframe, so it's a mess. So comment if it's too much. I can do the opacity, and I will put an opacity at 0.5. So the opacity is like the alpha. And as you can see, nothing has changed. It's like the opacity is not working. When you want to use things like alpha and opacity, it's the same thing, alpha and opacity. You also have to specify transparent, true, like this. As you can see, it's working. So if I put all three in the same axis like that, I can see that the transparency seems to be working. It's not always the result I could expect, but it's working. Okay, cool. Next one is the alpha map. Remember the alpha map? I can show it to you right here. So this is the alpha map, so it's a square, and the outside is black and the inside is white. What is white is going to be visible, what is black is going to be hidden. So I can use it. I will do material alpha map equal, and I already loaded the door alpha map, so I can do that. And it's not going to work because I forgot something. When I want to use transparency, I have to say transparent, I have to set the transparent property to true, like we did for the opacity. So I'm going to let it above. And as you can see, we have something happening. The alpha seems to be working, but it's kind of a mess because the texture is all stretched to match the UV coordinates. So, but it's working. It's what we wanted. You can combine with the map to enjoy a real door like this. So this is without the alpha map, and this is with the alpha map. Okay, cool. Another thing is about the side. If you try to look behind the plane, as you can see, there is nothing. And we can control this by using the side property. And we can put three different values. It's going to be front side, back side, and double side. The front side is the default one. So if I put 3.front side, it's exactly the same. What I can do is back side. So at the beginning, we won't be able to see the front side, and we have to go behind to see the back side. And I can also put double side, so we can see both sides, like that. So if you have, I don't know, a cube, and you can see the outside of the cube, and then go inside the cube and see what's inside the cube, you will use double side. Try to avoid using double side because it's more calculations for the GPU and the computer. Yeah. Many of these properties like transparent, opacity, side, wireframe will be available for the next materials, all right? And we are not going to repeat those. Maybe just sometime we are going to repeat those in order to remember this, but wireframe and stuff like that will be available for the next materials. That's cool. This was the mesh basic material. Let's try to remember those properties, and sometime we will use them. The next one is going to be mesh normal material. What I'm going to do is comment everything like that, so I can get back to it if I need. And you should do the same, it's up to you, but if you want to keep the code, just comment it and do a new material. So I use the same variable name in order to test a new material on all the three meshes. And the next one is a really cool one, which is new 3, and it's mesh normal material. I really like this one because it looks cool. I really like the color you get when you use the mesh normal material. So what is the mesh normal material exactly? Normals are information. We already talked about normals, but we didn't say much about it. Normals are information that contains the direction of the outside of the face. For you, it's maybe obvious, like if you take a sphere, the outside of the sphere is probably in that direction. The outside here is that direction. The outside, which is facing me, is going to my direction, and at the other direction is going to be at the opposite. Well, for our sphere, the outside is just the outside of the sphere. But for a computer, for the GPU, it's not that logical. We have to provide those informations. And when we are using 3 geometries, those informations are already provided. And we saw those information. If we do, let's say, you don't have to do it, just watch what I'm doing. Sphere geometry, I can access the geometry. And if I access to the attributes, as we already did, I get all the attributes associated with my geometry. And as you can see, I have a normal attributes. And there is a lot of data in here, and it goes 3 by 3 because in 3D, a direction has to be with 3 values, X, Y, and Z. Yet again, we don't need to provide those, not yet at least. Maybe if you create your own geometry, you will have to do that, but right now we don't have to do this. Okay, cool. This was just for your knowledge. The mesh normal material will show those direction. Oh, and by the way, I created an image in Blender to show you this. The idea with that is that the geometry contains normals, and the normals are the direction, and direction, it's like an arrow, like it's pointing in a direction. So if you get a sphere, the arrows are pointing outside of the sphere. But with more complex geometries, like Susan, it's the name of this monkey, you get something like this. All right, it's just a representation of the normals. But why do we need normals exactly? Well, it's about lighting, reflection, and refraction. All right, when you want to see the reflection on a sphere, when you want to light a sphere, how to know if you have something like a light like this, how to know if this side is being lightened and this side is not being lightened? Well, it's just because of the normal. If the normal is pointing to the direction of the light, which is right above the camera, well, this face should be in the light, so you should be able to see it clearly. But if the normal at the opposite of the sphere is at the opposite of the light, you won't be able to see anything because it's going to be in the shadow. So this is why we need normals. And yeah, like we said before, if I use something like wireframe equal true, I get something like this. So previous properties like wireframe, transparent, opacity, and side works. All right, we just have a new property, which is flat shading. And you can pass this, set it to true to enjoy what is flat shading. So remove the wireframe and you get something like this. As you can see, it's flat. We can see the faces. So we have two triangles here, and it creates some kind of square, some kind of rectangles, and we can see those because it's not smooth anymore. It's a different result. Maybe you need this. It depends on you, your project, and what kind of render you want. But you can do that with flat shading. All right, the mesh normal material is usually used to debug normals. Like if I remove the flat shading, I will be able to see the normals and see if there is a problem, like a normal that is not supposed to be that color or of default in the surface. I will be able to see those easily with the mesh normal material. But it looks so great that you can use it just like that. It's not... When we talk about performances, it's great too, so it's okay, you can use it, you won't have a frame rate issue. And actually there is a cool portfolio from Elifia, which looks just like this, which is exactly the case. It's normal materials. I'm quite sure she did use normal material. And as you can see, it looks just great. So yeah, you can just use it. It's really efficient, like you can just use it. if you like the color at least. All right, the next one is mesh matcap material. So again, I comment the material and I create a new one, and I'm going to do mesh material equal new 3 mesh matcap material, like this. This one is a little complex, but once we have it working, you will probably understand. So the mesh matcap materials will display a color by using the normals as a reference to pick the right color on a texture. So it's a lot in a row, in one go. You take a reference picture. So this is just a picture, all right? And we have multiple textures. The program inside the material, the mesh matcap material, will take colors inside that texture. It will pick the colors inside that texture to put it on the shapes like this. And it will take the color, the right color, depending on the normals relative to the camera. Wow, that's a lot. Let's just use one and you will probably understand. So I'm going to change the texture by using material matcap equal, and I have this texture already available, which is matcap texture, because we loaded this matcap texture right here. So I set the matcap texture of my mesh matcap material with matcap, the matcap property. And as you can see, I get something like this. And this looks just like this. See? It's exactly the same thing. One interesting feature is that if I turn the camera, I still get the same result. Look at the sphere. I get something like that. And here, maybe you understand what's cool with that, is we can simulate the light without having lights in the scene, which is great. We can simulate shadow, lights, and we don't have light in the scene. We are going to add lights very shortly, but we don't have light and it's working, which is great. All right, you can test other matcaps. I think it's the following part. Yeah, you can test the second matcap, which look even better. The third matcap, yeah, let's test them all just for fun. Yeah, you can have real reflection. As you can see, we can see windows inside. So it really depends on the matcap you're using. We are using this matcap, so it's just a reference image. We have this one. Why not? It depends on what you want to achieve. Yeah, this one looks great. Number 6. Oh, this one looks like flesh. Really strange. 7. Yeah, this one is interesting, like for cartoonish style. And we have 8. Yeah, I really like this one. The mix of color is really great. So yeah, where to find matcaps? There is this GitHub repository. I put the link as always. You can access it in the links panel with a lot of matcaps. See all those matcaps. Yeah, there is a lot of matcaps. You can use those matcaps, but be careful if you want to use this matcap and put your website online, or if it's for a client or professional usage, make sure that you have the right to use this matcap. You can also create your own matcaps in a 3D software, which I do a lot. All you have to do is put the camera in front of the sphere, put the lights as you want them, put the material on the sphere. So inside the 3D software, put the material on the sphere and do a render, a square render, and then you will get something like that, which is exactly what I did for my portfolio. And you can also create it in Photoshop. It's just, you don't have to do like a real sphere. All you can do is just paint huge with huge brushes, and you might get a good result. I did it for a few projects and the result was just fine. And if you don't like the result, just paint again, try to fix the color, do something dark at the bottom to simulate shadows, and it might look just great. You can do that inside Photoshop or GIMP or whatever. Cool, the next one. So it's going well. I'm going to comment this one. The next one is mesh depth material. So I'm going to do new 3 mesh depth material like this. And I can just use it like this. And I think I will get a result. All right. Maybe you won't see anything. Just zoom, zoom, zoom. And as you can see, we can start to see something. All right. If I move to the torus, it's hard to see, but it's working. The mesh depth material will simply color the geometry in white if it's close to the near of the camera. Remember the near and the far. So if the geometry is close to the near, we get white. As you can see, it's white when it's very close. And if it's close to the far, it gets black. All right. This can be used for many things, for creating fogs, for pre-processing, which is stuff we are going to learn way later. In our case, it just looks funny because you can have a silent hill effect. So why not? Maybe one day you will have to use this one, but actually we will use this one in a later lesson. You will see why exactly. All right, the next materials we are going to see, they need light. We don't know much about lights, and we have a dedicated lesson about lights. But we need lights right now, so we are just going to add 2 lights. Wait a moment. We are just going to add a few lights just in order to see those 2 lights, just in order to see those materials and how they work. And we are going to explain lights in details later. We are going to add an ambient light by doing, so I'm going to do, maybe we should do it like after the objects, so right before the sizes. As you can see, I recommend to always organize your code. I'm going to write ambient light equal new 3 ambient light. It's going to be white, and the second parameter is about intensity. We are going to talk about this later. Just add those in order to see the next materials. When you add, you create a light, you have to add it to the scene. And we are going to create another one, which is going to be a point. I will do point light equal new 3 point light. 0x like that. 1, 2, 3, 4. Okay, so that's good. 0.5, so it's not much, but it's going to work well. I'm going to do point light position x equal to, why is it doing this every time? Y and z. 2, 3, 4. And don't forget to add it to the scene, which is something I always forget. Point light. If you refresh, oh, there is an error, my bad. Oh yeah, it's because I commented the material. But if you refresh, you're not supposed to have error unless you commented this. And you won't see any difference because the light doesn't work on the depth material, on the mesh depth material. But the next material we are going to see are going to use those. So as I said, I did a mistake. I commented the material, which is why I have an error. But right now it's the same result, and if I move in, I get my depth material back. Cool. More about lights later. So I comment again the material, and we are going to use the first material that reacts to light, which is the most simple one that reacts to light. It's the mesh Lambert material. So I'm going to do material. Oh, I forgot, but as always, if you check the documentation, you have examples, and those examples are really cool. You can play with all the parameters we said, and we are going to discover some of them right now. But yeah, check the documentation. 3GS documentation is really cool. So I'm going to do new 3 mesh Lambert material and no parameters. And as you can see, I have something happening, which is great. I now have lights in my scene. All right. If you have nothing, check the light. Like, see, if I forgot to add the lights to the scene, I get nothing. Because maybe you created a light, but if you don't add it to the scene, it won't work. If you add just the ambient light, you get this strange result. And if you add the point light, you get this result. All right? I just wanted to show you if you have a different result than me, maybe it's one of those things you missed. So this is the mesh Lambert material. It's cool. It's cool because we are starting to have something realistic, which is a good start. We have new properties related to the light. All right, but we will see those later with more adequate material. It's just because we are going to see better materials that have the same properties. So instead of seeing those properties right now with the mesh Lambert material, we are going to see the properties with the next material. The mesh Lambert material is great. It's performant, really performant, but we can see strange patterns on the geometry. I don't know if you will be able to see them, but me, I can see them, but maybe with the video compression, you won't be able to see them, but look closely, not too close actually, at the geometry, and you can see like lines, blurry lines like this. All right? This is very specific to the mesh Lambert material. It's a problem, but at least this material is very performant, so we can have a great frame rate with it. The next one is going to be mesh Phong material. Mesh Phong material. And it's very similar. See the result? It's almost the same, but the strange pattern is gone. And we can see something like brighter here. You can see that some kind of light reflection. I can show you the mesh Lambert material again. So we have those strange artifacts, those strange patterns. It's brighter here, but we don't have some kind of reflection of the light. With the mesh Phong material, the bug, the artifact, the lines are gone, and we also have the light that bounce and get to the camera, which is cool. The only drawback is that it's less performant than the mesh Lambert material, but right now performance is not an issue. We don't have much things inside our scene, so performances, we are okay with that. That's cool. So there is one which is shininess. You can do material shininess equal, and let's try a random value like 100. And as you can see, we can enjoy the light reflection better. All right, test 100. You can test even more if you want. 1000 maybe. Yeah, see how shiny it is? That's cool. So I'll get back to this. And you can also change the color of it by using the specular. Specular, just like the color of mesh basic material, has to be a 3 color. So a color class. And I have this color class already open. So what you can do is specular. Should have been specular color, but anyway, new 3 color, and you can just put a color in it. I can put red like this, and I will get a red light reflection. Why not? It depends on the rest of the scene, but why not? I think I used a different color here. Red, green, blue. Yeah, it's bluish color. Yeah, we can see it better with this blue color. All right, cool. Why not? We can perfectly use this one. The next one is going to be mesh tool material. It's a funny one. Material equal new 3 mesh tool material. And the mesh tool material, I think you can just use it like that. It's cartoonish. You see, we get a sharp change in the color, which look just like this. Why not? And we can have control over it by providing a gradient. And we have our gradients right here. We have 2 gradients, and we cannot see much about it because it's very small. It's not blurry because this one is composed of 3 pixels, almost black one, a gray one, and a white one. But my Mac decided to blur it. And this is actually a problem we are going to have right now, but inside 3GS. So let's try to use this gradient. So if I get back to the top of the code, as you can see, I loaded the gradient. Make sure it's loaded well. And we get back to the material, and we can change the gradient by using gradient map equal and use a texture. And what's that? It looks more like a mesh Lambert. It's not bad, but we lost the cartoonish effect. And this is very interesting. What's happening here is that the Mac filters try to fix this very small texture, and it tried to stretch it, and it's blurring it by using the MIP mappings. And we already know about this. So if we want to prevent this, we can use the nearest filter. All right. And we can do that inside the texture. So it's on the texture, and I'm going to do it where I create my texture by doing min filter equal 3 nearest filter. And just in case, I'm going to put it there also with the mag filter, all right? If you're not sure about min and mag, maybe just use them both and the result will probably be just fine. And as you can see, we have 3 different values depending on the lightning of the scene. So it's looking great. We have a really cool result, and why not? It depends on your project, but if you want a cartoonish result, you can use that. And actually, there is another version with 5 different results. As you can see, I have a lot more. 1, 2, 3, 4, 5. 5 different steps. Because we use the nearest, we can deactivate the MIP mapping. Remember from the previous lesson, by doing generate MIP maps equal false. Oh, sorry, generate MIP map false. All right, and the MIP maps are not even generated. We cannot see this because MIP maps are invisible. They are sent to the GPU, but we cannot see them. Anyway, it's always better to deactivate them if we can, and we can if we are using nearest filter. Okay, that's cool. Let's get to serious things. We are going to use the mesh standard material. Focus on this one, it's very important and it's the best one. Depending on what you want to do, but you're going to use the mesh standard material a lot in the next lesson. So let's try this one, I'm excited. 3.mesh, I hope you are, standard material. And if you just do that, I think it's going to work. Yeah. You get a cool result. Actually, it's even a better result. It just looks better, like maybe smoother. The light just looks great. Cool. Like Mesh Lambert material and Mesh Phong material, it supports light, but with a more realistic algorithm and better parameters like the roughness and the metalness. Remember from the textures lesson, the roughness and the metalness. We can change those roughness and metalness. We can do material.metalness equal 0. I don't know, let's test the same value. Okay, it's really different, why not? And we can also change the roughness. I don't know the default value. I know the default value, but let's test this. And as you can see, I get very different results, which is cool. Instead of trying properties, we are going to create a debug panel. And we are going to do it from scratch, because I explained to you how to create a debug panel with that GUI, but we need to practice. So let's practice. It's going to be a little fast, so hang on. Don't hesitate to pause the video if you need. First, we need to add that GUI to the project. If you want to use something else, like a GUIFI or GUI control GUI, I forgot. Do it, but we are going to. I'm going to use that GUI. Open the terminal if it's not already open. If you want, you can create another terminal, or you can close the server. So Control C, and I'm going to install that GUI by writing npm install --save that GUI. It will add that GUI to the dependencies on the project, which they will go to the node modules folder. Do not access these folders. We don't need to go inside that folders, at least right now. And then you can run the server again. Don't forget to run the server again, because right now it's not working. You can just refresh this page. All right. We added that GUI to our dependencies. I can close this, and we can now import it by doing import star as that from that.gui. Pause the video if it's going too fast. Anyway, it's what we did in a previous lesson when we discovered that GUI. I repeat, what we want to do is be able to tweak the metalness and the roughness with the debug panel, which will be much easier to enjoy those properties. All right, I can create a debug part. There won't be much inside it, but still, it's going to be separated visually. And what you can do now is instantiate GUI by writing const GUI equal new that GUI like that. and I get my panel here. The panel is empty. We need to add tweaks, and we are going to do it right now. I prefer to add tweaks on the go. So it's going to be with the material. If I add tweaks about the geometry, I will do it with the geometry. If it's about the light, I will do it right after the light. You need to do it after creating the material, or you will have a JavaScript error because the variable doesn't exist. And what we are going to do is GUI add. You need to tell the GUI which object is concerned, so it's our material. And the second parameter has to be the properties that you want to tweak. In our case, it's going to be metalness. We are just going to focus on metalness right now and write the other one after. You can provide a minimum value. It's going to be 0. A maximum value, it's going to be 1 because the metalness goes from 0 to 1. I don't know if you can go below and above. Maybe you will have a result, but I think it's not logical. And mesh standard material is really logical. Maybe I forgot to talk about this actually. Oh yes, I forgot to talk about this. So we will get back to something right after. And let's provide a step, which is the precision, or I did a really small precision. And as you can see, I can now control the metalness of my material. Let's add the roughness with the exact same value, but it's going to be roughness. Don't forget the H. I always forget the H. And as you can see, you can just find the right value depending on what kind of materials effect you want to have. All right. So it was just an exercise. I wanted to practice that GUI with you. It was a perfect equation. Yeah, something I forgot to tell you is about the mesh standard material. Mesh standard material uses physically based rendering principles. And we talked about those physically based rendering principles. These are the PBR. These are the principles that tend to mimic the real life conditions to know how the light and the color are supposed to merge in order to get a realistic result. All right? It's just algorithm techniques that will get a realistic result, and it's becoming the standard, which is probably why they call this one mesh standard material. So you will probably have a very similar result with, I don't know, Blender when using PBRs inside Blender, and 3GS when using this mesh standard material with PBR inside of 3GS. Okay, we will talk about this later again and again. Yes, we can do that. Our material, so we can change the map by using door color texture like this. As you can see, I have my door, which is starting to get pretty realistic, which is great. So it's not very useful to test on the sphere and the torus. I just wanted to show you the result with the round surfaces. We are going to focus on the center plane mostly. All right. We also have access to AO map. The AO map stands for ambient occlusion map. If you remember in our textures, let's get back to the texture, we have this one. And this will just add shadows in the crevices of our texture. It's just to make things darker when it's supposed to be like a crevice, so in the shadow. It will add contrast and a little of details. But this one is not easy to add because 3GS want us to provide another set of UV coordinates. You remember the UV coordinates? The UV coordinates will tell how the texture is supposed to be applied on the geometry. And we need to provide another set of UV coordinates. And what we are going to do, because the set we want is just the default set, like if you look at this texture, I want my ambient occlusion to be applied the same way on it. But still, we have to provide these attributes. So we are going to duplicate the current UV coordinates and name it UV2, which is exactly what 3GS needs. To do that, remember that you can access the UV coordinates. We are going to do it on the plane. You can do log plane geometry. This will let you access the geometry because we declare the geometry inside the mesh directly, but we still can access to it. So this is a plane buffer geometry like this, and we can access its attributes like this. So this is the attributes, and as you can see, there is the UV attribute. And we are going to duplicate it, so we can access this. And if you remember from the geometries lesson, we have to do plane geometry and use the set attribute to add a new attribute to the geometry. We did that to add positions. So we are going to do set attribute. We are going to choose a name, and it's going to be UV2. And this is what 3GS needs. So we didn't choose this one. 3GS needs a UV2 coordinates in order to place the ambient occlusion on the texture. And we are going to create a new 3 buffer attribute. If you don't remember this, it's perfectly normal. It's hard. I don't want to show it to you right now because we are still beginners, but if we want to see the ambient occlusion working, we have to do it. And we are going to use the UV array. I will comment it to show you that there is an array inside the UV attribute right here. And these are just the values. So it's a plane. A plane is very simple. We don't have much inside. So we are just going to use that array and send it to the attribute right here. So it's going to be an array, and I can take this and put it right here. I'm going to do line breaks in order for you to be able to see all of this code. Yeah, something like this right here. And I forgot something very important. You have to tell to the buffer attributes how many values compose one vertex. So it's an array. We have many values in the array. The first 2 values will be for the first vertex. Then the 2 other values will be for the second vertex. And then the 2 next values will be for the third vertex. All right. So it's going to be 2, because UV coordinates has to go 2 by 2. I did it just fine. We can do it for the rest of the sphere. I know it's a lot of code, but we have to do it. It's not that important for the other one, but let's do exactly the same. So it's going to be sphere, sphere. And we can do it for the plane too. And it will look some, sorry, not. We already did the plane. What did I just do? Plane geometry. Okay, that's it. For the torus, like this. And it's going to be torus, torus. So I did the exact same code for the sphere at the beginning, right here. We already did the plane. And I did it for the torus right here, which is the code we have here. I know it's a lot of code that bother me. If you want just to focus on the lesson, do it. It's okay. We don't use AO maps, so ambient occlusion maps, that much. If one day you need it, just get back to the lesson and you will do it and understand. All right, we can save. I didn't use the texture yet, so we are going to use it. Material. AO map, so it's not ambient occlusion map. They wrote AO map equal ambient occlusion. So it's DO ambient occlusion texture. Let's save. And as you can see, it's darker here in the crevices. I can show you better if I remove it, just to compare. As you can see, it feels flat. I put back the AO map. And as you can see, we can just enjoy crevices. It's just a little better. Yes, the AO map could have been inside the texture. It's actually slightly different because it also acts with the light, stuff like that. So it's better to have it in the AO map, in the ambient occlusion map. It's just to have like the perfect render. You can use those ambient occlusion texture. A lot of effort, I agree. Oh yeah, and you can change the intensity by doing AO map intensity. Almost forgot about this. I'm going to use 1. Yeah, we can see it even more. I don't know if I change it, maybe 10. Oh yeah, we can see it. Let's not use 10. And if you want, you can add it to that UI. Well, you know what? Let's do it. I'm going to do material AO map intensity in the second argument, and it's going to be from 0 to 10, and I can use the same step. And as you can see, I have my AO map intensity, and I can crank it to the end and enjoy the right value and find the right value as I want. Again, I can show you by zooming, like that. Okay, that's cool. Yeah, this one is cool too. A little easier than the AO map. We are going to use material and displacement map. It's going to be a mess at start. Don't worry, we are going to fix that. So one interesting thing is that here it's called displacement map, but I call it height map inside the texture. It's just so you remember that height and displacement are the same, all right? So we use displacement map. I use the door height texture. Let's see what we get. Oh, what is that? So it's a mess. There are multiple problems here. First, we don't have enough vertices in our geometry, which is why our plane in the center didn't even move. We don't have enough vertices. And remember, we can just activate the wireframe. Don't do it, I can just show it to you. These are the vertices, so it's just two triangles. If you want to move the vertices to create some displacement, well, with that much vertices, you won't see much. So I will remove the wireframe, and we are going to fix that. First, we are going to add subdivisions. It's going to be on every geometries. So let's start with the sphere, and we are going to use 64, 64, like that, on the sphere buffer geometry. All right, it seems much better. Cannot enjoy it a lot, but it seems better. We can then go to the plane buffer geometry and add more subdivisions. Don't forget that the first parameters are the width and the height of the plane, and the other parameters are the subdivision. So it's going to be 100, 100. Okay, that's cool. It's very strange door, but it's working. We have more details. We can enjoy more precision with the 8 map. And we can do that for the torus too. Let's not forget our torus, which is over there. Yeah, it's going to be 64 and 128. All right, it's working too for our torus, which look in a bad shape. Poor torus. The other problem is that it's too strong, all right? Yeah, it's working, but we don't have doors like this, even in France, don't worry. So yeah, we need to reduce this effect. So yeah, let's go. I'm going to use material, and it's going to be displacement scale, and just use a smaller value like 0.05. It's way less, but we can enjoy just enough in the door. Maybe you can't see enough, but it has to be subtle. If it was a terrain, we could crank it up, but it's not, it's a door. So yeah, we can enjoy it. And you know what? Let's do the same. I'm going to duplicate the roughness, and we are going to add the displacement scale to our debug UI. Let's use that debug UI and let's play with it. All right, it's working. We should match on a sound and do this kind of animation. All right, that's cool. Let's move forward. We also have the metalness and the roughness. So let's just change those. Remember that these are I forgot to show you the 8 map. When it's white, it goes up. When it's black, it goes down. And when it's right between white and black, so it's gray, it doesn't move. The last one I wanted to show you are the metalness and the roughness. It's the same textures we use in the previous lesson. We can change those by doing material metalness map equal door metalness texture. And let's use the other one, which is roughness. So I'm going to copy and paste because I'm lazy, like that. And it should be working. And as you can see, we have a difference, but it looks like it's too much, right? If you test here, see right here, it's working. We have a difference in the metalness and the roughness, but it doesn't look good. The problem is that we are combining maps, so metalness map and roughness map, with the metalness and the roughness properties. And when you use the metalness and the roughness like this, it will also apply this value on the maps. So you should not combine them. So what you can do is comment them like this, and now I get a nice result, the result that the designer wanted for this door. Or you can use the default values, which are 0 for the metalness and 1 for the roughness. And it looks like this, which is fine. We can still change those if we want. All right. But let's use the default one. It's fine too, at least for this example. All right. I think we are almost done with the material. What we can see now is the normal map. And this one is really cool. We are going to do material. So I can show you the image first. It's this one. If you remember, it will add details without having to do a lot of subdivisions. And you will see the result right now. We are going to use normal map equal door normal texture. Look at this. See the details? Yeah, we have a lot of details. I remove it. And as you can see, the door is flat, at least in the center. I add the normal map, put the camera below, and yeah, we have a lot of details. It looks great. Those details are cheap. I mean, yes, it's things to calculate for the GPU, but it's much better than having thousands and thousands of vertices, so we can use a height map on it. So yeah, try to use normal map if you can. We can actually change the strength of the normal map by using normal scale, which is a vector 2. So because it's a vector 2, I can do like x equals something else, or I can use set 0.5, 0.5. I think it's going to be less visible. Yeah, it's more subtle. All right, just a little more. If you use way more, like 0.1, as you can see, we can barely see the results. It depends on you, it depends on your project, and you can add those to that GUI. I won't be doing it right now. Pause the video and do it if you want. Finally, we can control the alpha using the alpha map. And we already did, but we are going to use it anyway for this mesh standard material. My goal here was to have the perfect door. So we are going to add the alpha map, which is this alpha map. We already used it, this in the mesh basic material. So alpha map equal door alpha texture. And I did a mistake. Look at the result. No error, but still I don't have this part, which is, I can still see this part. I'm not supposed to be able to see it. It's because I forgot to set the transparent to true. If you want to play with the alpha, with the opacity, you have to use transparent equal true. And see the result? Yeah, we have a beautiful door. Congratulations. So it was a lot of work, but still we have a great result. It wasn't that much work, we just took our time. So yeah, we are almost at the end of the lesson. We have still some cool things to see. The next one, we are not going to spend too much time on it. It's the mesh physical material. We just need to understand it. It's the same as the mesh standard material, which is the one we just saw, which is the one that got us this result, but with a clear coat effect. And the better way of understanding this is by using those examples, which are 3GS examples. You can access the examples just by clicking on the example tab right here. And as you can see, it's realistic, but we have a clear coat above the surface. So it's just more realistic. It's very specific to very specific objects. So it depends on what you're trying to do. But if your material is supposed to have a clear coat above it, you can use the mesh physical material. If you don't need this clear coat, do not use the mesh physical material. It's more calculations for the GPU. Okay, the next one, that's a lot. Don't worry, we are going to use them. The next one is points material. You can use points material to create particles. And we won't talk about this right now because we have a lesson dedicated, we have multiple lessons dedicated to particles. So we are not going to see this one right now. Shader material and raw shader materials, it's the same. We have a lot of lessons dedicated to it. It's when you want to create your own material, so it's not 3GS built-in materials. You will use maybe the shader material, maybe the raw shader material. What's the difference? I don't know. We will see that together later. So it's not for this lesson. All right. One cool feature we can use right now is the environment maps. I'm going to close this. I don't need the color anymore. Well, anyway, I will let it just in case. The idea is that we are going to use environment map. The environment map is an image of what is surrounding the scene. So you provide what is supposed to be outside of the scene. It can be used to do reflection or refraction, but also to do the lighting on the on your mesh. All right, and we are going to do that when we are going to do realistic renders. I'm going to show you how to get a very realistic render, and we are going to use environment map to create light on the object. We are going to use environment map right here in a more simpler way. The problem is that it's hard to load. So yeah, let me see. Yeah, first we're going to tweak a little the metalness. You know what? We are just going to comment this. We are going to keep the material, the metalness, and the roughness. So we can comment all of it. Duplicate this, just those three first line. Pause the video, take your time. I want something that looks like this. You can do your own, but I recommend to have this to enjoy what we are going to see about environment maps. So it's metalness 0.7 and roughness 0.2. And we get this. All right, cool. And you can let the GUI, it's not a problem. So yeah, there are multiple ways of using environment maps. 3GS, at least right now, only supports cube maps. So we are going to have to create cube environment maps. I provided you some environment maps inside the static textures environment maps. So we are going to use maybe the first one. Yeah, this one is great. And then we are going to test the other one to see a different result. So how do we load those environment maps? First, we are not going to use a texture loader. We need to use a cube texture loader. I told you that there is multiple types of loader. We are going to use a font loader, and we use the texture loader. We are going to use model loaders. It's going to be GLTF, stuff like that. And right now what we need is a cube texture loader, and as always you have the documentation and you can simply use this code. But we are going to do it together. So let's go. I'll go up with my textures. I'm going to create a cube texture loader, so be careful with lowercase, uppercase, stuff like that. And it's going to be cube texture loader. If I save, no error, fine, let's move on. So it's very similar. I'm going to put the code right here at the end after loading the texture, and we are going to do const cube texture, environment map texture equal, and just like we did with the texture loader, we are going to use the cube texture loader, use the load method, and instead of just using one path, we are going to provide 6 paths. Why 6 paths? Because as you can see, these are like photos of the surrounding, photos in that direction, behind, on the left, on the top, and on the bottom. So this is why you get something that looks like this. Okay, cool. These are huge environment maps. We can be a problem in terms of performances, but we don't have much in our scene, so it's okay. So yeah, let's put the path. I'm going to write the first one. So be careful. I use the brackets. So add the brackets because it's an array of 6 paths. So the first one is going to be textures environment maps, and it's going to be the first environment map folder. So it's going to be 0, and you have to provide the environment, the images in the right order. So it's the positive x, so I use px.jpg, and then you will provide the other 5, like this, yeah? So it's positive x, then negative x, which is probably there and there. Then it's going to be positive y and negative y, so top, bottom, in our case. Then it's going to be positive z and negative z. You have to know this order, or you will have a very strange result. So you just have to know the order. And you can check the documentation to see this order. Yeah, see? Px, nx, py, so it's positive x, negative y, and the rest. So it's JPEG. I think I'm done. No error. Cool. If you have an error, let's say you did something wrong here, you wrote something wrong. As you can see, there is an error. Try to find the reason for the error, fix it, and get back to the video. So yeah, how can we use this? It's pretty simple. So I take my texture, my cube environment map texture. I get back to my material. So we did a lot of material, which is cool. We practice, it's important. And we're going to do material and map equal, and we simply use that environment map. And here is the result. That's perfect. We have our scene, our environment map scene, reflecting on our objects. And you can play again with those. See the roughness? Yeah, this is looking great. If it's a smooth surface, which means the roughness is at 0, you can see the environment inside of it. No, you won't be able to see yourself or to see the camera because there is no camera. We can play with the metalness and get a very different result, like this. You can get something like that looks just like metal, so it looks right like this. And if it's a rough metal, we get something like this, which is awesome. Thank you, the Mesh Standard Material. Thank you to the guys that did the PBR, so the physically based rendering. It's just great. We have cool results. So yeah, you can tweak the metalness and the roughness, which is exactly what we did. And what you can also do is replace the 0 by the other maps and see the result. As you can see, like I'm in the nature. I can test the 2. Yeah, looking great. And I can test the 3. Looking good too. And you can play with the values again. So yeah, really nice. We are going to use environment maps and also discover other features with those. So I provided you 4 environment maps, but what if you want to use other environment maps? Well, as always, what I used to do is a simple search on the web, all right? And sometimes I found the right thing. First, make sure you have the right to use those environment maps, all right? It's not because it's on the web that you can just use them. Make sure you have the right. If it's for personal projects, go ahead. But if you put it online or you use it for client projects or for I don't know, you get money from something of that WebGL experiment, you have to make sure that you have the right to use them. It's very important. There is a website, which is the website that everybody uses. Not everybody, but it's a very famous website, which is called HDRI Heaven. Heaven, I don't know. Which is this website. And this website is just awesome. Thank you, Greg. Go to this website, choose environment map. So I have to go to HDRIs. And I can just use any of those. I don't know. Which one do you prefer? I use already this one. I like it, but I already use this. There is too much choice. All right, I will go for... Okay, this one. Anyway, just choose one. If you download it, so be careful, this is an ad. I'm going to download, I don't know, the 4K version. Yeah, why not? Maybe the 2K version. Let's use the 4K version. We have different qualities. What I want to show you is that this is the environment map. And as you can see, it's not the same as we have. So if I show you again what we had before, we have like a cube composed of 6 faces. And right now, all we have is this. How do we get the cube maps textures from an HDRI texture? And first, I forgot to tell you about HDRI event. haven't, is that it's under CC0 license, which means you can do almost anything you want with it. Just check the license. You can use the HDRIs for any purpose, including commercial work. You do not need to give credit, even if it's good to give credits, just like I did right now. You can redistribute them, so if you want to give those HDR, you can. Still, if you want to thank those guys that are helping and putting those HDR, you can by following their Patreon. I put the links with all the other links. Okay, cool, of the Patreon. So I downloaded the environment, the HDRI. What you can do is use that website. This website will allow you to upload an HDRI. So you just click on upload the HDR, download, so it's in my download folder, and I provide this. I can change values, but what I can do is go to CubeMap view and see this result, and this is exactly what I want. So you can change also the orientation, and you can do save. You can choose which result do you want. We want separated images, so we're going to use this one. You can click on process. Just wait a little, you can save, and it's going to download the CubeMap version, and it will look like this, and this is exactly what we wanted, and the name are just fine. So I can take this one, put it inside my folder, I can call it, I don't know, 4, and then I can change this. So be careful, it's by default PNG, so you have to change the number, but also the type, the extension of the file. And as you can see, I have the results, and if I move the roughness down, yes, this is exactly the HDR I downloaded. Okay, and that's all for the materials. We are going to use them, so maybe it was a little too fast, but do not worry, we are going to use many of those materials, mostly mesh standard material, but the other ones too, like matcap materials. We are going to use the matcap material shortly. See you in the next lesson.